Welcome, everyone. You're listening to Decoded by AssetIntel. I'm Ashton, part of the team here.
And I'm Ashley, also with AssetIntel.
This is our third episode, and today we're doing a deep dive into something maybe you haven't thought much about, but it's incredibly important.
Definitely. Think about the bridges you cross every single day, on your commute, maybe heading out for the weekend. They just seem solid, dependable.
Exactly. You don't really give them a second thought, right? They're just part of the journey. Seamless.
And that's how it should be. Infrastructure should be so reliable we just trust it. But there's something happening, often unseen, right under the water, flowing past those bridge supports.
A hidden threat. It sounds a bit dramatic, but it's very real. It's this relentless force, the erosive power of water, and it's called scour.
That's right. And scour isn't just, a minor issue. It's one of the biggest challenges bridge engineers face, really, all over the world.
Yeah, and we're basing our discussion today on a really insightful blog post from our team here at AssetIntel. It really digs into why scour matters, the risks, and crucially how technology, especially monitoring software, is changing the game and protecting these structures.
It's our roadmap for today, essentially. It covers the science, the risks, the solutions.
Absolutely. So our mission here is to unpack that blog post, pull out the key insights for you. We want you to understand what scour actually is, why it's such a serious risk, how we've traditionally tracked it, and how technology is revolutionizing bridge safety today.
It's about getting you informed on this vital topic. It's fundamental to the resilience of, everything we rely on.
Okay, let's get started. So first things first, what is scour? The blog defines it pretty clearly.
Yeah, it's basically the natural process where flowing water, in rivers, lakes, even coastal areas, washes away the ground around bridge foundations.
The ground, like the soil and sand.
Exactly. The sediment, the soil, sand, gravel, whatever the foundation, the piers holding the bridge up in the water, or the abutments connecting it to the land, whatever that foundation is sitting in, water erodes it, carries it away.
It's a natural process, but when we put a bridge there.
Right, that natural force becomes a problem for our man-made structures. The water's energy is literally undermining the bridge supports. It's like washing the soil away from the roots of a tree.
Okay. And that makes the foundation unstable.
Precisely. It removes the support. The soil provides resistance, bearing capacity. If that washes away, the foundation is weakened. It's losing its grip, essentially.
And the blog post highlights something really important here. It gets worse during floods, right?
Oh, much worse. It accelerates dramatically. When you have storms, floods, the river swells, the water moves faster, it's more turbulent. That fast-churning water has way more power to pick up and carry sediment away.
So a bridge could be fine for years, then one big flood hits.
And suddenly the scour that was happening slowly becomes really dangerous, really fast. And the blog is clear. If it's left unchecked, scour can actually cause a bridge to collapse.
That's terrifying. It's not just some abstract risk.
No, it's a documented cause of failures, a serious threat to public safety. And that connects right back to you, the listener. The bridges you cross, you're trusting they're stable.
Which is why proactive monitoring is so critical. We can't just wait until we see a problem.
Definitely not. By the time visible signs appear, like an exposed foundation, it might already be too late, especially if a flood is happening. You have to monitor the risk before it gets severe.
And that's where the modern bridge scour monitoring systems come in, like the ones discussed in the AssetIntel piece.
Right. These systems, often powered by smart software, they allow engineers to be proactive. It's about moving from occasional checks to continuous data-driven assessment.
Getting ahead of the problem. Now, the blog also breaks down scour into different types. It's not all the same kind of erosion.
No, and understanding the type is key to fixing it. The source mentions three main ones. First is local scour.
Local, so like in one specific spot.
Exactly. Right around individual bridge parts that block the water flow, mostly the piers in the water or the abutments on the banks. The structure itself causes turbulence.
So the water swirling around the pier digs a hole.
Pretty much. The blog explains it well. The water flow creates these downward currents, like little whirlpools or vortices right at the base. They act like drills, eroding the soil right there, digging a scour hole.
Okay, that makes sense. Concentrated erosion. What's the second type?
That's general scour. This is broader. It's not just around one pier. It's an overall lowering of the riverbed across a wider area.
The whole river bottom drops. Why?
Could be lots of reasons. Changes upstream affecting sediment, maybe dredging downstream, or just long-term erosion. The point is, this overall lowering can affect multiple structures in that waterway, not just one bridge. The foundation embedment depth decreases for everything.
A much bigger scale problem, potentially affecting the whole river system. Okay, and the third type.
Contraction scour. This happens when the waterway gets narrower. Maybe the bridge opening itself is narrower than the river, or there's debris buildup.
Like squeezing water through a bottleneck.
Exactly. And when you force the same amount of water through a smaller space, it has to speed up. Higher velocity means much more erosive power. That faster water just rips away at the riverbed in that narrowed section.
Higher speed, more power. Got it. And knowing which type, or maybe a combination, helps engineers figure out the best fix.
Absolutely. Is it local turbulence? Is it the whole channel changing? Is it the contraction effect? That dictates the solution, maybe adding rock armor, maybe channel improvements.
So we know what scour is, the different forms, and that it's a serious threat. Let's really dig into why that consistent monitoring is so crucial. It's more than just identifying the type.
Oh, absolutely. The blog lays out several critical reasons. And the first, the absolute top priority, is public safety.
Has to be. Keeping people safe on those bridges. That's the bottom line.
It is. The blog emphasizes protecting lives, and it mentions, the potential for catastrophic failure. It even points towards the I-35W collapse we'll talk about later, a tragic example of what happens when scour isn't managed.
Preventing tragedies like that. And the software plays a key role here, catching early warnings.
That's the core idea. Intervention before crisis. The software integrates data, spots subtle changes, erosion rates, flow patterns, things you wouldn't see with the naked eye until it's maybe much worse.
So engineers get flagged early.
Yeah. And that consistent data-backed monitoring allows them to step in. They can make timely repairs, stabilize things, maybe even close a bridge temporarily if needed before structural integrity is compromised, keeping bridges safe and operational.
Beyond just immediate safety, the blog also talks about maintenance and longevity. How does monitoring help there?
It's all about the data. The software provides this continuous stream of info, erosion rates, water speeds during floods, sediment loads. It's not just a snapshot.
And having that data lets engineers do what exactly?
It lets them be smarter about maintenance, implement preventive actions. Instead of just reacting to damage or sticking to a fixed schedule, they can use the data to predict where scour is likely to worsen or when it's accelerating and focus their efforts there.
So it's more predictive, less reactive.
Exactly. Condition-based, data-driven maintenance. And the big benefit, helping the bridge last longer. These are massive, expensive assets. Extending their life saves enormous amounts of money compared to replacing them early.
Which leads right into the next point the blog makes, cost efficiency.
Yeah, this impacts everyone's wallet, ultimately. Using advanced monitoring software can lead to really significant cost savings.
How does that work? By avoiding the big emergencies?
Primarily, yes. Avoiding emergency repairs or, worst case, full bridge reconstructions after a failure. The blog states very clearly those unplanned large-scale fixes are way more expensive, orders of magnitude more than routine maintenance or targeted proactive fixes guided by monitoring data. Fixing small scour issues early is vastly cheaper.
So investing in the monitoring tech saves huge costs down the road.
Precisely. And that directly saves taxpayer money that would otherwise go to emergency responses, complex repairs, or building entirely new bridges because of scour neglect.
And it's not just good practice, there's a regulatory context too, right? The blog mentions federal guidelines.
Yes, the FHWA, Federal Highway Administration, has guidelines under the National Bridge Inspection Standards, the NBIS.
And those standards require scour monitoring.
They require agencies to assess all their bridges for scour vulnerability. And for those bridges considered vulnerable, they must implement specific monitoring protocols. It's a mandate.
So it ensures a consistent approach across the U.S.
Right. Consistent evaluation, safeguarding infrastructure nationwide. It underlines that this is a recognized national priority.
Good to know there are standards driving this. Okay, so we know why monitoring is vital. How do engineers actually get this data? The blog covers the methods, from traditional ways to high-tech stuff.
Yeah, it's a whole toolkit, ranging from visual checks and manual measurements right up to sophisticated sensors and remote sensing, with software bringing it all together.
Let's start with the traditional approaches, just looking at it, I assume.
That's the starting point. Visual inspections. Skilled inspectors physically go out, examine the structure, the piers, abutments, the riverbed nearby.
What are they looking for? Obvious damage.
Visible signs, yeah. Exposed foundations, parts that should be buried, signs of erosion, sediment movement, cracks or movement in the bridge itself that might relate to foundation issues.
But you can't see everything, especially underwater or during a flood.
Exactly. That's the big limitation. Visibility is poor when scour is often worst, and access can be dangerous.
So how do they measure what they can't see?
Traditionally, using scour depth measurements, the blog mentions sonar and probing rods.
Sonar, like on a submarine. Ping.
Kind of. Sound waves bounce off the riverbed. Measuring the return time tells you the depth. It maps the bottom, including scour holes.
Then probing rods. That sounds simpler.
It is. Basically, long poles pushed down to feel the bottom, a direct physical measurement of depth near the piers.
Okay, so measuring the depth of those scour holes over time tells you how fast it's happening.
Exactly. Comparing measurements shows the erosion rate. Crucial information.
Then the blog talks about the increasing use of instrumentation. This sounds more automated, more continuous.
It is a big step up. We're talking sensors installed permanently or semi-permanently around the foundations, often underwater.
What do these sensors measure?
Key factors driving scour in real time. Things like water flow speed, how much sediment is being carried. There are different sensor types for this ADCPs for velocity, others for sediment concentration.
And this real-time data goes where?
Straight into the bridge scour monitoring software. That's the key. Continuous analysis, 247 updates, not just snapshots from visits.
A huge difference. Continuous surveillance. The blog also mentions predictive modeling, using computers to forecast.
That's the idea, specifically hydraulic modeling. Engineers create detailed digital models of the river, the bridge, everything.
And they simulate floods in the computer.
Sort of. They input channel shape, sediment types, flow rates. Then the model calculates how water flows under different conditions, normal flow, major flood stages.
What does that simulation tell them?
It helps assess potential scour risks. By modeling how velocity and turbulence change during floods, they can see which parts of the bridge are most vulnerable before a flood happens.
Running what-if flood scenarios to pinpoint weak spots.
Exactly. It helps prioritize monitoring and plan mitigation strategies based on predicted vulnerability.
Okay, those methods are valuable, but the blog really emphasizes how technology has revolutionized things recently. Better accuracy, faster data.
Yeah, this is where we get into the real advanced stuff. Technology has transformed monitoring more accurate, timely data, monitoring in previously impossible conditions, all feeding powerful software.
First up, remote sensing and drones. Sounds futuristic.
It felt that way not long ago, but now it's practical. Drones equipped with LiDAR, that's light detection and ranging, and high-res cameras.
LiDAR makes those super accurate 3D maps, right?
Yeah.
How's that used for scour?
It maps the riverbed topography, the banks, abutments. Drones can even fly under the bridge deck for close-up inspection. They capture precise 3D data showing changes, erosion, deposition.
From the air or just above the water?
Both, depending on the tech and conditions. Some LiDAR can even penetrate water to map the bed. They provide incredibly detailed data.
And the blog highlights a big advantage: doing it without shutting down the bridge.
Huge advantage. No lane closures, no boats needed for many surveys. It's faster, safer, less disruptive, and the data quality is amazing.
Then there are the advanced underwater sensors. We touched on them, but the blog stresses their importance in modern systems.
Absolutely essential for continuous data from that critical underwater zone. These are rugged, submersible devices.
What's the key difference from just measuring depth occasionally?
Continuity and real-time capability. They continuously monitor flow rates, sediment transport, maybe even scour depth directly, right at the foundation.
And the main benefit?
Real-time alerts. This is critical during floods when scour accelerates rapidly. If velocity spikes or sediment surges, engineers know instantly, not hours or days later.
Allows for a much faster response when things get dangerous.
Exactly. It's proactive awareness during the event itself. The blog also covers geophysical methods, seeing below the surface.
Right, peering into the subsurface without digging, like ground-penetrating radar, GPR, and electromagnetic surveys. GPR uses radar to see underground.
Basically, it sends pulses down, reads the reflections. Different materials, layers, or voids like hidden scour reflect differently, mapping the subsurface.
So it can find erosion happening below the visible riverbed.
Yes, identifying hidden risks without intrusive methods. It has another layer of understanding. And this data integrates seamlessly into the monitoring software for a complete picture surface, real-time, and subsurface.
Finally, the analysis tools. Machine learning and data analytics. This is where the software gets smart.
Definitely. These algorithms are the engine. They take all that data, sensors, surveys, models, and turn it into actionable insights and predictions.
How do they predict scour?
They learn from historical data, past inspections, sensor readings, flood records, weather patterns. They identify relationships between factors like water speed, sediment, and observed scour.
So they learn patterns to forecast future problems.
Precisely. Considering complex interactions, they provide forecasts of where and when scour is likely to become problematic, especially during anticipated floods.
What's the impact of those predictions?
It helps bridge owners make smarter decisions, allocate resources better, focus inspections or maintenance on the highest risk areas identified by the models, schedule preventive actions. It's moving from reaction to true prediction and prevention.
This mix of sensors, data, and smart analysis is clearly powerful. But let's look at the real-world impact. The blog gives some examples.
Yeah, case studies really drive home the stakes, both the tragic consequences of failure and the successes of good monitoring.
First, the really sobering one. The I-35W Mississippi River Bridge collapsed in Minneapolis, 2007.
A terrible tragedy. It really brought scour, which was often an overlooked engineering issue, into the public eye in a devastating way.
The blog calls it a stark reminder of the dangers.
Absolutely. And the investigations afterwards found that scour had weakened the structure, contributing significantly to the failure. While design flaws were the primary cause, the report noted scour reduced support capacity, making the collapse worse.
So scour wasn't the only cause, but it made the bridge much more vulnerable.
Exactly. It compromises overall stability. And the consequence, a nationwide wake-up call. States reassessed their practices, and it spurred the widespread adoption of modern bridge scour monitoring systems. A tragic lesson, but it led to vital changes.
A hard way to learn. The second case study is more positive. The Golden Gate Bridge.
Iconic bridge, vital link, but in a really harsh environment. Strong tides, deep water, potential earthquakes makes it very susceptible to scour.
And the blog says they've done extensive monitoring.
For decades, they've been leaders in using advanced methods. The blog mentions sonar mapping, potentially drones, and advanced scour monitoring software, bringing it all together.
A comprehensive, high-tech approach.
Definitely. And the result, engineers have kept that bridge safe and sound despite the challenging conditions. It shows that robust, proactive monitoring really works.
These examples really highlight the extremes, failure, and success. Looking ahead, the blog talks about the future, especially with climate change.
Yeah, that's a major factor now.
How does climate change affect scour monitoring?
Well, the science suggests more frequent, more severe extreme weather, bigger floods, more intense storms.
Which means more stress on bridges.
Exactly. Scour monitoring becomes even more critical. Bridges face greater erosive forces more often. Designs based on old flood data might not be adequate anymore. The challenge is growing.
So what future advancements does the blog suggest are needed?
Continued focus on enhancing monitoring software and systems. One key area is interagency collaboration.
Agencies sharing data.
Right. State DOTs, federal agencies, local groups sharing scour data and resources for the same waterways. Scour affects entire river systems, so the coordinated regional view is crucial for effective management.
Makes sense. Building a bigger picture. What else?
Public awareness campaigns. Educating the public about why bridge maintenance and monitoring are so important.
Why is public awareness key?
To build support for funding. When people understand that this work directly impacts their safety and the reliability of roads they use, they're more likely to support the necessary investments. It's not just abstract spending.
Connecting the work to daily life.
Good point. And research and development.
Yeah, ongoing research into more resilient materials and designs, building bridges that can inherently withstand scour forces better from the start, maybe different foundation designs, tougher materials.
So better tech, better collaboration, public support, and stronger designs. A multi-pronged approach.
Exactly. Improving how we design, build, monitor, and maintain bridges for these increasing challenges. Which leads us to innovative solutions addressing these challenges now. The AssetIntel blog specifically mentioned emergencyX.
Right. And the blog frames it in that broader context. Protecting infrastructure isn't just about scour, it's about readiness for any emergency event.
Scour, earthquakes, floods, other disasters.
Yeah, and emergencyX, based purely on the blog's description, is presented as an innovative platform for both advanced scour monitoring and that wider emergency preparedness.
What does the blog say it does?
It's described as a powerful platform to help infrastructure managers respond quickly to threats, mentioning scour risks and natural disasters specifically. It comes from us, AssetIntel.
And it's positioned as being for monitoring during extreme events.
Exactly. At the forefront of software for tracking infrastructure during extreme weather, which ties right into the climate change discussion.
What are its capabilities, according to the blog?
It integrates real-time data from all those sources we talked about: sensors, drones, geophysical tools, weather forecasts, stream gauges.
Pulling it all into one place.
Yes, consolidating the information. The benefit highlighted is enabling a swift, coordinated response. With all the data in one platform, managers can assess situations rapidly and make informed decisions during fast-moving events like floods.
And for Scour specifically, it enables that proactive response.
That's the idea described. Monitoring scour as it develops during a flood, seeing the real-time data, and deploying resources crews, engineers, before serious damage occurs. Moving from reaction to informed, proactive intervention when the risk is highest.
So it's presented as a tool combining the tech, the data, the analysis, and the need for rapid response.
That's the value proposition described in the source. And the blog's concluding thought reinforces this, that tools like emergencyX, providing real-time data and predictive analytics, make the future of bridge safety brighter.
The investment isn't just about protecting concrete and steel.
No. The blog frames it as saving lives, protecting the economy, ensuring reliable transportation for generations. It connects the tech back to the core purpose, keeping people and goods moving safely.
Okay, wow. We've covered a lot from that AssetIntel blog post today. We defined scour, that hidden erosive force.
Talked about the different types, local, general, contraction, and really dug into why monitoring is critical. Safety, longevity, cost savings, regulations.
We traced how monitoring evolved from visual checks and probing rods
To drones, LiDAR, underwater sensors, geophysics, and the incredible power of machine learning and software integrating it all.
We saw the real world impact the hard lessons from I-35W, the success of the Golden Gate.
And looked ahead at climate change challenges and the need for collaboration, awareness, R&D, and innovative solutions like emergencyX.
The big takeaway, I think, is that proactive, tech-enabled monitoring isn't optional anymore. It's fundamental to keeping our vital infrastructure safe.
Absolutely. It's complex work, battling nature's forces, but the tools are getting better and better.
And for you listening, the next time you drive over a bridge, maybe take a second. Think about the engineering, the inspection, the constant monitoring happening beneath the surface, often using technologies like the ones we've discussed, working to keep you safe. It gives you a new appreciation, right?
It really does. It highlights that constant effort to balance our structures with powerful natural forces, and how much we now rely on technology to observe, analyze, and predict to maintain that balance.
So, based on the insights from the AssetIntel blog post we've discussed, the final point is really a call to action for the agencies listening who manage this critical infrastructure.
Right. The source suggests that if you're responsible for bridges and waterways, exploring how advanced solutions can help is the next step.
Specifically, the blog concludes by recommending that agencies schedule a call with us here at AssetIntel. It's presented as the way to have a detailed discussion and explore how a platform like emergencyX can help protect your specific assets from scour risks and other threats.
Definitely worth looking into how these integrated systems can enhance your monitoring and preparedness efforts.
Absolutely. Well, that wraps up this deep dive for Decoded with AssetIntel. Thanks for joining us.